All right, good. Okay, perfect. We are in business. Screen share, screen share. Okay, sweet. All right, so if you go to your Canvas, go to your modules, have you already done your attendance question for the day? Yes? Okay, so those of you that are watching this on Zoom, do your attendance question, and then you can see we are doing lesson 3-1. Wait, nope, this is the wrong week. My bad. Go back to modules. We need to be in week 6. Okay, so make sure you're in week 6. And what I like to do is close the other weeks. So like week 5, we're done with. So I can close that one up. I don't have to be distracted by that. And then open up week 6. Okay, so I've got week 6 there. It's open. You've got your attendance question. And then you can see 9:28. We're working on elimination. Okay, so with this class, we've been working on 3-1 for 2 class periods, and then today will be the 3rd. So on Friday, I had a short video for you, and then you did your Delta Math, okay? And then today, it's pretty much the same thing, okay? Okay, that's okay. You can, or you can just write on a piece of paper and then submit paper notes. It doesn't have to be in the book. What do you mean? Yeah, like if you write them on a piece of paper, then you can submit that. That way you don't have to do it twice or whatever. Okay, so it says complete class notes by Zooming or watching back. Make sure you write your name. Okay, I am wanting you guys to do that now. There's been some cheating going on. Some people are just submitting other people's pictures. So make sure you write your name on there. And then it says when you finish your class notes, you'll go to Delta Math. All right, so we are doing elimination. All right, so what are the other methods that you've already learned? Graphing and substitution. Okay, so those are the methods that we have already learned and mastered. So that is going to be where we're continuing to go. Let me get my correct book. Okay, so what page are we on, y'all? Page 34, is that correct? Yep, 34. Okay, so with graphing, you remember that what we're looking for is the point of intersection, okay? They can have one solution, which means they're going to touch one time. Was that this computer? That was yours? Okay. All right, so you could have one solution where they touch once. You could have no solution. That's the result of parallel lines. Or you could have infinitely many. And that's the result of the lines being directly on top of each other, one on top of each other. With substitution, it's the same thing. You could substitute in and end up with having either no solution or infinitely many. Same thing with elimination. If you do have those cases, what is that going to look like? Well, you're going to end up, when you're solving, having a number equal to itself. So when you're solving, the x's are going to cancel out, and you'll end up with 2 equals 2, which is a true statement. If that's what you end up with, then that's going to be infinitely many. If the x's and y's cancel out, everything's gone, and you end up with a false statement, then that is no solution. 90% of the time, you're going to have a single solution where you end up with x equals 2, plug it back in, and get your y. Okay, so that's typically what you're going to see, but I just wanted you to know these special cases are possible for you to get that. Okay, if we look at this first one, they gave us a word problem, and we're going to be using the elimination method. It says over here in our math terms, if we look there, it says in the elimination method, you eliminate one variable. Multiply each equation by a number so that the terms for one variable combine to 0 when the equations are added. Then use substitution to find the value of the variable to find the value of the other variable. The ordered pair of the solution is the solution to the system. The elimination method is also called add-elimination method or linear combination method for solving a system of equations. Now, when you do your delta math says that you can also subtract, okay? So when you do elimination, typically we do addition and we add, but it is possible for you to subtract and have the same result. So when we're talking about eliminating, you are going to want your x value or your y value to be opposite of one another. Y'all put y'all's mask up. So if we have 2x plus 3y equals 6 as one of our equations, and then another equation is, I don't know, 4x minus 3y equals 12. Okay? If you're looking at this example, your y's right here are opposite, which means they have the same coefficient. One is positive, one is negative. If that's the case, then all you have to do is simply add them together and they will eliminate. So 2x plus 4x is 6x. Your y's give you 0, so you don't write 0y equals 18. Okay, then we would divide by 6. So x equals 3. Isn't that right? 3 times 6 is 18. So that's that. Then, to get the y value, you take that and you plug it in to either of the equations. It's not going to matter which one. I'm going to do the first equation. So 2 times 3 plus 3y equals 6. 2 times 3 is 6 plus 3y equals 6. I subtract 6. That gives me 0. 3y equals 0. How do I get the y by itself? Divide by 3. What's 0 divided by 3? 0. So our solution would be 3, comma, 0. That's with addition. Okay, that's adding them together. And that's what you're seeing with this word problem too. Okay, they're creating opposites so that they can add them together. The difference with my example that I just showed you and their example is, like, if you look right, hold on. If you look right here, you can see right now that's just an n and a q, or an x and a y, whatever variables, it doesn't matter. But this n and 5n are not opposite because they don't have the same coefficient. Same thing with the q. This q and 25q are not opposite. So they're having to create an opposite. The way they do that is they multiply everybody by -5. When they do that, that allows you to have a -5 here and a +5 there, then it eliminates. Okay? So let's just look at a couple more examples that they have in this book, and then I will let you work on your delta math. All right, so if we look at A, let me make that small so I have plenty of room to write. All right, when we look at A, right now we have -2x minus 3y equals 5 for equation 1. In equation 2, you have -5x plus 3y equals -40. Do you have opposites? Yeah, your y's. Okay, you've got a -3y and a +3y. If that's the case, then you don't have to multiply by anything. You just simply add them together. So let me rewrite mine. So like David, if you just show your work for this, like, you don't have to have the book for that. This would count as your notes. So we're just simply going to add these together. What's -2x and -5x? Okay. Then we have -3y and +3y. Those are going to cancel. Then we have 5 plus negative 40, which gives us negative 35. Then what do? That's right, divide by negative 7. So x equals positive 5. Now you're looking for the solution. So that's just the x variable. How do we get the y variable? Plug it in. Does it matter if we plug into equation 1 or equation 2? Which one do you guys want me to use? The first one? Good choice. It literally doesn't matter. All right, so we've got negative 2 times 5, which is negative 10 minus 3y equals 5. I'm going to add 10 to both sides. Negative 3y equals 15. Divide by negative 3. So y equals negative 5. So I've got my x as 5 and my y as negative 5. So my solution is 5, negative 5. Okay. Now, from here, on the second one, you still have your two equations, equation 1 and equation 2. Do you have opposites? No, not currently, which means we're going to have to create opposites. You create opposites by multiplying. So, do you want it to be 5y and negative 5y? Or do you want it to be 6 and negative 6? You just tell me because it doesn't matter. 6 and negative 6. Okay, so if we're going to make this become negative 6, what do we have to multiply that by? By 3. And we need to multiply the whole thing by 3. So I'm going to go ahead and write equation 1 because that's not changing. You don't have to change both. I'm just going to change the second equation. And when I change that second equation, I'm going to multiply everybody by 3. Everybody. So now equation 2 is going to be 3 times x. What's 3 times x? 3x. 3 times negative 2. What's 3 times negative 2? Negative 6y. And then 3 times 10 gives me 30. Now that you've multiplied by that 3, do you have opposites? Yes. So you are going to add them together. What's 5x plus 3x? 8x. What's 6y and negative 6y? They eliminate. Negative 14 plus 30 is that 16? Divide by 8. So x equals 2. Now we've got x. What do we do to get y? Which one do you want to plug into? The bottom one, go back to the original number 2. Okay, so we're going back to the original number 2. So that's just x, which now is 2, minus 2y equals 10. Then I'm solving. I'm going to subtract 2. Negative 2y equals 8. Divide by negative 2. Y equals negative 4. So what's the solution? That's right, 2, negative 4. All right, C is going to be the more challenging because it's not an easy fix. Well, kind of it is, I guess. But like if you look, the x's don't match, the y's don't match, so you're going to have to multiply to make them match. So what do you want to do? What do you want to multiply by? Multiply by negative 3. And that's perfect because if we multiply by negative 3, that's going to make that positive 3, which is what we're looking for. We already have a negative 3, so we're multiplying. That's going to make it positive 3. So that's going to give me positive 3x. Negative 3 times negative 5y is positive 15y. Negative 3 times negative 17. I don't know what that is. What's that? Negative 3 times negative 17 is 51. You said that, didn't you? Sorry. Okay. So then we bring over negative 3x plus 3y equals 21. That one's not changing. Okay, that does not change. That one stays the same. So I just brought equation 1 over. We multiplied by negative 3 to get this one. Once you get here, you just add them together. Negative 3x and positive 3x do what? Eliminate. 3y and 15y gives me 18y. 21 and 51 give me 72. So then we have 72 divided by 18. That's going to give me 4. We have y. How do we get x? Plug in. Which one do you want to plug into? We'll do the first this time. So we've got negative 3x plus 3 times 4 equals 21. Because it really doesn't matter where you plug it into. You'll get the answer no matter what. So then this is going to give me 12. So I'm going to subtract 12 from 21. What's that? 21 minus 12. 9. I thought it was 9, but I just wasn't sure, so I didn't want to be wrong. Okay, then we divide by negative 3. So x equals negative 3. What's the solution? Negative 3, comma, 4. Okay. All right. Well, that is how you do elimination. That's your notes. So that's what you're submitting to me. Make sure you put your name on both pages or wherever your notes are. So when you submit that, I have your name on there. And then go to Delta Math and complete that assignment. Let me know if you have any questions. Anybody Zoom in have questions? Charles? All right, if not, I'm going to end our lesson.